Okay, before I start, is there anything which is a bit unclear about what we've talked about so far? It's conceptually, it's all been review, we're just learning things that you already know, and this is how we do them in Java. The biggest challenge so far has been the strong typing, which you may not be used to, coming from untyped languages like Python. And some of the biggest gotchas on that have to do with, well, the biggest gotcha on that is integer division. So that's just something you have to watch out for, and just whenever you're doing a division, just have like a little red flag that says, okay, is there at least one double in this? And if there isn't, then what can you do? You can cast one of the integer variables to a double, just with the parentheses. So you all know how to do that. And I mean, that's something that does not arise in an untyped language. I mean, there's no such thing as a cast in Python. Why? Because there's no such thing as a type. Well, there is, but it's all under the hood. It's one of these things where they're going to do it for you. So in those languages, if you define two variables and assign them integer values and then go to divide them under the hood, Python, you could argue, is a little smarter than Java. It says, oh, you're dividing two integers, but I'm going to upgrade at least one of them to floating point values and then perform the computation. So you might say, well, why is Java so anal about this? That's actually a good thing. Strong typing is a necessity if you're building large programs like simulations, which we're going to be doing like whenever we use a little bit of random stuff, it's like a little simulation. I'm going to have you do one of those this week, but that's like a little thing, more of a classroom exercise. For big projects, strong typing is absolutely essential. I mean, there's just sort of no. Well, people argue about that on the internet. I can just tell you my experience, and my experience is that strong typing has been crucial in all of the large programs that I've developed. So, okay, so today we're now going to delve into objects, and like in the lessons, it's now in the next. Are you able to kind of see where we are in the lesson links and everything? Okay, so as we move from one topic to the other, I'll be putting the various links and things in hopefully the appropriate place. Okay, so objects, that's one of the primary reasons why use Java. Or an object-oriented language. Java is not the only one. It wasn't the first. It's not the last. It's arguably not the best. There are other languages that have pure object models. There are other languages. There used to be a big religious war between Java and the C++ people, saying this one's better, no, that one's better. Just like they each have their pluses and minuses. They're tools, for Christ's sake. So, and your job, whatever it is to match the tool to the task. Whatever that might be. So it's not, like the old cliche about a hammer in search of a nail and whatever. Just you use the right tool. I mean, and it's helpful to have more than one tool in your toolkit, therefore. Okay, so objects. What object variables are, again, that's something important to understand. That's something that Java did, kind of looked at experience of mostly of the premier object-oriented language at the time, which was C++, and there was this kind of weird thing about how C++ did objects that Java, in my opinion, fixed. Now there are C++ people that'll kind of argue the other way, but all right. So how do we create objects? Again, that's that's actually a topic that's going to involve some more concepts. So we're going to touch on it, and we're going to keep circling back to it. Invoking methods on object references. That's if you remember early on, I said there are no functions in Java. What we have are methods. And what's the difference? A function is something that's just kind of out there on its own. A function doesn't have any connection to anything else. In Java and in object-oriented languages, a reference is something which is intimately tied to a particular object and will typically operate on data within that object. And that is kind of one of the keys, principles to why this object-oriented idea became so important a few decades ago. Okay, and then we're going to we're going to take a look at some strings and then apply some of these method invocation concepts on strings, because that's been the main object we've seen so far. We're going to see another very useful class called String Builder, and we'll take a look at that. Okay, so objectives for today are to understand what an object reference is, as distinguished from the primitive variables that we've seen so far. And you should be able to invoke a method. That's fairly easy. And then see some useful string methods, and then you should be able to create a string builder and use it to concatenate some long strings, as we'll see. Okay, so creating objects. So a variable holds either a primitive value or a reference to an object. And notice that I've italicized reference because, oops. Give me your thing here. Okay, so this is one of the distinctions between Java and C++ and other types of languages. Because what we're ultimately going to be doing in part is using these object references to either invoke a method and sometimes using them as variables as arguments to another method. What happens when we do that? And this is where other languages are very complex, because you can either pass the whole value or pass a pointer to the value. And in Java said, we're never going to pass the whole object. We're going to pass a reference to it, which is just a single word, and that just sort of saves a lot of copying and everything. And the other thing is the difference between a pointer and a reference. Now, have you used pointers in other languages? Probably, yes, a little bit. Okay, so what's the difference between a pointer and a reference? And it may seem like nitpicking, but it's an important one. In Java, a reference simply refers to an object, whereas a pointer actually points to the object. Okay, so, all right, you're just kind of repeating the words, but what's the main difference? The main difference is that when a pointer actually points to the object where it is in memory, where its location is in memory, and in a language where that pointer can be treated as an integer variable, what you can then do is operate on that pointer and say increment it by 1 and whatever. And the source of a lot of malicious code is based on that. That is grabbing a pointer to something in the program, but then starting to increment it. And because it's actually physically pointing to a place in memory, you can actually step out of, it would be like, are you familiar with the holodeck in Star Trek? No, kind of. But okay, so that I can't go with that reference. I got that reference. Yeah. So anyway, well, okay. So in Java, that's literally impossible. Okay, for two reasons. One is the Java virtual machine creates what's called a sandbox, and you literally cannot, unless it's been implemented incorrectly, there is no way that any part of the program can get out of that sandbox. In other words, it kind of walls off a piece of memory, and there's nothing in the program that can get out of that if it's been implemented correctly. Now, if there's a bug in how it's been implemented, you might be able to exploit that. So far as I know, that's never happened. The other thing is that unlike a pointer is an integer, and you can modify it. You say you don't have to remember that because we don't deal with pointers. A reference is not an integer. You can't take a reference and add 1 to it. In a pointer, if you take a pointer and add 1 to it, it moves to the next location in memory. A reference, you literally cannot do that. You try to do it, the compiler won't let you by. So that's. Okay, so get off the soapbox here. Okay, so when we declare a variable, so like we've been declaring primitive variables, and then now if we declare a variable to be a class, in this case string is a class, and then title is an object reference of type string. Why do you do that? Okay, so now that's simply a declaration. That's actually not even an executable statement. It just says this variable is going to be of this type. And so under the hood, what happens is it just says, okay, that's what's going to be. Now, depending on the context, if it is okay, now you don't have to remember this, but if it's an instance variable or a class variable, at this point, it will actually have its default value, which is called null. If it's a local variable, it's actually undefined. The thing to understand is that there's no object that's created. So this is simply a declaration. So you can think of the object reference as holding the address, and I really need to put that in quotes because the address actually is not, again, unlike a pointer is literally the place in memory where the thing is. A reference is a quote address, but what that doesn't bear any relationship to where the thing is in memory. I mean, physically somewhere under the hood, there is a place in memory where it is, but Java kind of keeps you walled off from that. In other words, you have no idea where that is going to be in actual physical memory. So it's just kind of it's a virtual address. Okay, so now the object itself has to be created separately, and how do we do that? With two exceptions. Every object is created using the new operator. So what new does is always new followed by the name of the class. And depending on what arguments may or may not be required, that will create a new object, and that's called instantiation. In other words, we create an instance of that particular class. Okay, so this evaluates to in this case, a string object, and this assigns that string object to the variable title, which has to have been previously declared as a type of string. This is what this does is this calls something called a constructor. And what the constructor does is it constructs the object, hence the name. Every class has at least one constructor. Now that was actually something that was a little different in Java. In languages like C++, you don't have to have a constructor. It turns out that if you don't, then all kinds of weird stuff happens. And so Java said, you have to have a constructor. And if you don't write one, Java will write one for you. So when we kind of do a deeper dive into constructors, we'll kind of look at what that can do is that can create some confusing error messages based on what Java is doing under the hood. And so when you understand that, then you can understand what the confusing messages are. What are those confusing messages? We haven't seen them yet, but we will. Okay, so that's an object. Now, once we have instantiated an object, then we can start in what do you do with it? Well, one of the things that we can do is invoke a method. In fact, that's pretty much the only thing that we can do with an object. So an object consists of two pieces. It consists of data and behavior, or more specifically, instance variable and methods. So the instance variables are the data, and the methods are the behavior. So in this particular case, this num_chars would have to be an int. So here's a method on the string class called length. And notice that I forgot the semicolon. Okay, now, and this can be a little confusing. All arrays have a variable called length. So if I'm asking how long an array is, I ask it for I say .length, but I have no parentheses. Why? Because it's a variable. But for a string, it's a method. For the method requires the open and close parentheses. So this is we use this dot operator, and this says invoke the method called length with no arguments on the title object, which hopefully has it. Now, if that object does not have a method called length, the compiler will not let you run the program. So that's one of the benefits of that, and that's one of the downsides of interpreted programs like Python. I mean, this has literally happened to me, where I forget the exact one, but it was an error like that, where I was trying to do something like this, and it didn't happen for a long time. But when it happened, all of a sudden it blew up. Why? Because of a syntax error. Because I was trying to invoke a method on an object that it didn't have it. So you say, well, what if this object reference refers to a class that does not have this method? The compiler will not let you run the program. Okay, so now a well-named method is going to be almost self-describing. Almost, now you want it to be as describing as possible. So in a string, what would be your guess about what the length method does if I invoke it?
It's the number of characters in that string.
Exactly, and that makes perfect sense, and hopefully if a method has been implemented in a natural way, then that's exactly what it does. So now there's no such thing as a completely self-documenting name, but you want your names to be as compelling as possible. So that's the case here. So now a method may return a value. Actually, all methods syntactically have a return type. And that value is just one value, and we can use that value in an assignment or an expression. Here we're using it in an assignment, but we could also use it in an expression as well. So another way to think of it is asking an object to perform a service for us. So in fact, there's a whole framework or orientation called service-oriented something or other. And it's a useful frame in certain contexts. Okay, so now, so a primitive variable let's delve into this reference thing. It contains the value itself, but an object variable contains the address of the object, an address in quotes, meaning the address within the virtual machine, which is not the same as the address within memory itself. All of this is happening in the CPU, so in the memory there. So we can think of it as a quote pointer to the locale. We can think of it that way, but it's literally not that way. Okay, so graphically, so here's a number, and the contents. So like if this is declared to be an integer, the contents of the thing it's referencing is the number itself. So here num1 has the value 38. Whereas here, now notice that a string is going to, under the hood, it's going to consist of these different characters. And that's how it's actually represented. And we can actually kind of access that a little bit, but only when it's totally necessary. So the name variable is actually referring to some other stuff where these characters are kind of located. So the active assignment then takes the copy of a value and it stores it in a variable. So for example, for a primitive type, say if I have two numbers, 38 and 96, so there they are. Then if I execute this statement that say num2 is equal to num1, then afterwards it takes the value of num1, 38, and it stuffs it into the contents of num2. Now the thing is, the same thing is going on when we use object references, but it's like it's important to kind of understand that. So okay, so here's something very similar. So we have name1, where this object reference is referring to. Way under the hood, there are these characters which are located somewhere in memory, and when we instantiated the string, what it did was it said, okay, we have 2, 4, 6, 8, 10, 11 characters. It'll allocate the space for those characters and put these specific characters in there. And once we do that, actually, that particular object itself cannot be changed. Once it's in there, that's it, no more. And then similarly in this name2, when we declared it, we said, okay, you're going to refer to a string, and then when we instantiated it, we had that string point, if you will, or refer to the place in memory where these characters were kind of lined up one after the other. But now look at what happens if we say, now if we're going to say name2 is equal to name1, now the same thing happens as before with the primitives. That is, we take the value in here and it gets put in here. But what does that do now? So these two references now literally have the same value, but what is that value? That value is a reference to that same, in this case, that same set of characters. See, so even though under the hood literally the same thing happens, what's going on is now the objects are kind of looking at different places here. So now why is that important? Let me kind of illustrate that. And so far we only have been dealing with a handful of objects that kind of be doing that. Now let's see, let me make sure that I'm up to date. Okay. So now strings are immutable, but there are objects which are a little more mutable. So far, the only one we've seen have been arrays. So let's, here's what I'm going to do. Let's, okay, I'm going to declare okay, I've declared two int arrays. Okay, and remember, arrays are objects. So even though these are primitive, even though the contents are primitive, the array itself is an object. Now, one of the issues is that, like, if I try to print one of these out, as we've done with a string, we're going to look at. Okay, this is what we get. We get something that's not very useful. All right. But now what's happening here? Something similar with strings. So the variable 1 is referring to a place in memory where these three values are being held one after the other. And likewise 2 is now pointing to a different area where these three values are likewise one after the other. But what happens? Okay, so let's print, say the first element of this and the first element of that. Okay, so just to double check, I should get 2 and 4, okay? All right, so now let's do this. Okay, I have taken this and assigned it to 1. Now these are both pointing to one place. And now let's say I've kind of forgotten that, and I take my first array, and I'm going to set the first the element with index 1 to the value 13. So what's going to happen to my to this object? It's going to be 13. Okay. Why? What's happened is that both of these variables are now pointing to the same array, and so if I change one, it changes the other. Okay. So that's the little gotcha there. Okay, and that's one of the differences between primitives and object references. Okay, and that. Okay, and they're basically that they became aliases, meaning that I have two variables and they're actually pointing to they're referring to exactly the same object. And so the situation which I just illustrated is that there was one object there, that one array, but it was accessed using two different variables. And if I did something to one, in that case it changed the internal state of both of them because it was referring to the same one. So you have to be very careful with that because it can produce some weird stuff. Okay, garbage collection. I mean, that is something which sort of it was kind of an issue in a non-garbage collected language like C++. The user, when you created an object, it stayed there forever. And so what would happen is you would have something called a memory leak, which means you keep creating objects and pretty soon you run out of memory because there's only even with the size of memory that we have now, there's only a finite amount of it. And I mean, especially in large simulations, there are lots of objects being created, and so it's very easy to kind of run out of memory. Now, what Java, they didn't invent this. They borrowed this from another thing. But what garbage collection is that sometimes you create an object and then you're kind of done with it. How do you know when you're done with it? Well, if there are no valid references to that object. See, what happens is, remember I talked about scope. Okay, scope is within the curly brace thing, and when you kind of leave that, then variables can go out of scope. So if I create an object within a block, say, and then I leave scope, that object is still around. And in a non-garbage or a collected language, all of a sudden I'm screwed now, because that piece of memory is being taken up by an object. I have no references to it, but it's going to stay there. And if I keep doing that, it will gradually fill up memory until I run out. What Java has is under the hood, it's got this, it's actually got a very low priority thread that kind of is always running. And it's basically a garbage collector. It's kind of looking around for object references that are not valid anymore. And when it finds them, it says, oh, I'm going to free up this memory so that it can be used for other things. That's garbage collection. Okay, so more on strings. Strings and arrays are the two exceptions to creating objects. So ordinarily, we have to use the new operator to create a string, and we actually can. The string actually has a constructor in which you give it the string that it wants, containing the. Basically, you have to create a string to pass it to a string. So it's like a bit of catch-22. It's like reminds me of a video game I was playing a while back where you had to get into this building, but it was guarded by, had a guard there, and it says, I'm sorry, you need a pass to get in. I say, where do I pass? It says inside. So they had to go around back and break in, but that was, so there's kind of a catch-22 here. So strings, in fact, strings are really the building blocks of everything. If you think about it, the source code itself is just a long string. And so what we have programs that process strings and turn them into other stuff. So a compiler, for example, is something that takes the string of source code and turns it into these byte codes. And then of course, the virtual machine is something that takes byte codes and turns them into an executable program. Okay, so this only works for strings, and arrays are the only thing where we create objects that don't use new. Okay, so now the thing is that, again, and it bears repeating, strings are immutable, so we can't change the contents of a string. We can't change its length. We can't add more stuff to it. It's immutable. However, say, well, okay, well, so what can we do? Well, what we can do is we can create new string objects that have properties that we want. How do we do that? We use methods. See, in a procedural language, we'd have to have functions where you would kind of give it a string and it would return the right way. And here we have methods where they operate on the data that's in the string. So here are just a handful of some of the useful methods. There are some incredibly powerful methods that we'll be dealing with later in the course. We can take a string, we can kind of split it up into pieces. We can apply something called regular expressions to determine whether or not it meets certain criteria. But just right off the bat, here are some useful ones. So, and they're pretty well named. So we've seen length. That returns the number of characters in the string. Okay, this one is called toUpperCase. What do you think it does? Yeah, capitalizes everything. Well, now, and the thing to understand is that it returns a string in which all of the contents of the string you invoke it on are capitalized, but it does not change the string itself. So that's to lowercase does the same thing. Now here there's usually there's some arguments here. We'll replace. So I can take a string and I can replace certain elements of it. It actually has one called replace all, so I can replace all things of that. Again, the thing to remember is it does not change the string itself. It returns a new string which has the properties that you've given it. Substring, again, a very useful one where I can say extract a piece of the string. And again, it does not change the string. It returns in this case, a piece of it. And this one is sometimes useful, very rare, but occasionally. Question?
Since it doesn't change the original one, it just returns a new one.
Correct.
You have 2 pointers pointing to the same string, and you use references, not pointers.
Yeah, yeah.
You have 2 references pointing to the same string. You use one reference to call, say, replace to replace something. Will those 2 references now be pointing to 2 different strings?
Okay, let me when it each of the ones that return a string create a new string, a completely different reference, and so the original. I mean, if I were to take the variable that's referring to the original string and refer that to the return of the string, now it's referring to the modified one. But I still haven't changed the string itself, the original one. Is that, because it can be, you know, and I have to confess that I have on more than one occasion forgotten this, you know, so I can invoke these things and I think that I'm changing the string, and it's something to keep remembering, yeah.
So sir, in that example, that original string no longer has a valid reference to it, right? So the router's correctly distributed.
Correct, as long as there weren't anything else
Right.
referring, yeah, if I do that. So,
Makes sense.
yeah. And what we're gonna, let's see, I mean, I had, there was something I wanted to, okay, we'll circle back to this and look at some more examples. If I have time today, I'll look at, I'll do an example of that. And you know, just sort of going meta for just a second. When it comes to programming, it's important to actually become a genuine computer scientist. Now, the thing is that computer science isn't really a science. They kind of put the word science on it to make it seem more than it is. You know, it's like political science. I mean, political science isn't science. You know, biology is science. Chemistry is science. Physics is science. Political science isn't. Computer science isn't science. Okay, so what's science about? Or especially, you know, if you're one significant part of science is you perform experiments. You form hypotheses, and you perform an experiment to either verify or invalidate the hypothesis. So what do I mean? To be a programmer is to be an effective programmer, to literally be a computer scientist. Okay, what does that mean? That means that when something like this comes up, that you write a little program and hypothesize what's going to happen and see whether it happens or not. So I encourage you to kind of do that as much as possible, because documentation isn't 100% reliable, and sometimes our intuition isn't reliable either. So this is something which, I mean, occasionally I might want to refer to a particular character. When I say occasion, this is something that every now and then comes up a little bit, but the only use case I've found for this is that there have been cases where I want to capitalize like the first letter in a string, in a name or something. So I can capitalize the whole thing with 2 uppercase, but I don't want that. I only want to capitalize one. And so what I usually have to do is I have to grab the characters, turn a character into an uppercase and then create a new string with the new character array. So, but that's only, only occasional. One of the most important methods in that everything is a method called toString, and that's a pretty well-named method. It's one that all objects in Java have. Okay, now how can that happen? That happens because of the way that the class hierarchies are organized, and we'll get into that in a big way. But for right now, it's like all objects have a method called toString, and what toString does is it basically takes that object and it produces a string version of it. That's what we've been using when we kind of print something out. So when we pass, like what does print line do? And there's also a print that doesn't have a new line. When we pass an object reference to print line, what it does is it invokes the toString method on it. Now, because every object has one of these, the default is mostly uninformative. And in fact, if you remember back here, let's see, did I do it? Okay, this is the toString of this array. And as you can now, actually, if you know how to decode it, this is the quote address. There's an @ sign here, and then if you understand that this I stands for integer, and the bracket says that it's an array. So if you kind of know this and you see that, I can see that this is an array of type integer, but it's otherwise uninformative. And in fact, it would be nice if arrays had a toString where it would actually print things out in a more informative way, but it doesn't, and that's something we're gonna hopefully have time for, because we're gonna use String Builder to a lot of times when we're either concatenating long strings, or if we're in a situation where we don't know how many, we're going to concatenate a whole bunch of stuff, usually converting from like an array into something else, we can use one of these String Builder things. So here's an example. Here's a simple example, kind of unnecessary, but so here we instantiate a String Builder, and then it has a method called append, and we can append characters, we can append numbers, we can append strings. And so what this does is, under the hood, this is kind of the equivalent of a string expanding array. So if you remember in Python, if you can create an array, and even if you say I only want 3 things in it, if I put a 4th one in it, it'll expand to do that. And so Java's arrays don't do that, but something like this does. And so here I've created it. I add this, I append this string, I append this character, append this string, another character, and then the results, so now if I say toString of this String Builder, that returns another string which consists of all the characters that I've put in there.
So just to clarify, that result is not a reference to String Builder. It's its own separate object.
Absolutely, and in fact, we can sort of figure that out, because it cannot be a reference to a String Builder, because String Builder and string are 2 different classes. And so because of strong typing, once I declare a variable to be of one class, I can't assign another class to it. Now there's an exception to that, but only when we talk about inheritance. That's kind of when we'll get into that. So here's an example, where it might be useful. We want to output the contents of the array to the console. Notice that the toString of that was this kind of weird thing. And the thing is, we don't, quote, know how many elements are going to be in there until runtime. And so, actually in this, if you've, I think it's called, no, stringify array. So here's how to, here's a way. So what I'm doing here is I'm saying, okay, first, I'm using, remember our random object here? So I'm not going to know until I actually run this how many elements are going to be in this. So now notice that when I instantiate an array, it requires a positive integer inside the brackets. In this case, I'm going to say some value between 1 and 29 in this case. And now I'm going to assign for each, now at this point, the contents of data are its default value of its type, namely 0 in this case. So at this point, this will have a bunch of zeros in it. So I want to give it something else. So here I'm going to give it just random numbers between 0 and 99 in this case. And then, okay, so I print that out. That's not informative. So now I can use string builder. What I want is I want something like maybe with square brackets to kind of show what the contents are. So I'll create a string builder. I'll begin with a bracket. And then here, notice I'm using the for each on this. Why? Because I don't care about the index. I just want to buzz through all of them. So inside this block, the value is going to be the next element of data, and I'm going to append it to my string builder. And then I'm going to put a comma and then a space. And then I could have done it as a string. Why am I doing it as characters? In a way, this may be a little anachronistic, but remember that if I use double quotes, it's a string. And when I use double quotes, under the hood, it's instantiating an object. And that's fairly expensive. Whereas here, if I'm referring to a character is just a number that's pre-stored somewhere in memory. So this is like lightning fast. So now, for this particular example, there's virtually no difference. But in some larger cases, you might want to squeeze a few cycles out, or it may be just kind of my old mentality so that I have to get over. But regardless. Okay, so I'm going to buzz down the whole thing. And then when I'm done, I'm going to append now just a little, the closing bracket. And now when I print the toString for this, and I could have just printed the string builder itself, but I want to emphasize that it's the toString that's being executed here. And so now when I run it, we see that it all gets stuffed out here. Now the one, and I kind of deliberately left this in, and the one weakness here, notice that there's kind of at the end, I have like a final comma and a space. So, how can I fix that? Well, it turns out String Builder has some very useful things. Actually, because String Builder itself, unlike a string, is mutable. I can actually delete, and what I can do, I can also find string builder, oops, not capacity. I want the last index of comma to its capacity. So what that will do, see what that's going to do is that the last index of comma is going to be this one. The last index, well, at this point, because I haven't appended the bracket, the capacity is then going to delete this. And so what this line will do is this will then cut off that last little bit. And so now oops, I did it too soon. Okay, now notice I'm getting different lengths here, so I have to do it after there. Let's get a longer one. Okay, notice each time I run it, I'm getting a different length because, again, I don't know until runtime how many of these I'm going to have. And so I can't, the only hard-coded things in here are like the parameters of this, but it's like the data itself, I don't know how many there are. And that's why I need to use things like these 4 things. In this string builder thing, again, the first iteration, I had something, it had a little bit of a cruft at the end, and this is how I can do that. So string builder is now does have mutable data. So if I want to be creating strings and then modifying the strings themselves, then string builder is a way to do that. Okay, and then here, actually, the code is there. All right, so that does it for today. And then read ahead in Foundational Java. We're going to look at packages and libraries and things like that. And we'll see you then.